Hello, my name's Michael Fitzgerald and I'm the current Chief Editor of AstroEDU. So I'm just going to let you know a bit about where we're at with AstroEDU. So recently we transferred it to the Office of Astronomy Education, and in the background there's lots of tinkering and coding, getting some sites transferred over and some things updated. But that's now all completed and ready to roll. Just before the Office of Astronomy Education took everything over, there was a couple of things that we were working on in the background. One of the largest pieces was transferring the editorial process from being a bunch of spreadsheets which someone had to manually keep track of who was editing what and reviewing what and where and how it was all going, to an automated process using the open source open journal systems that enables automatic reminders, keeping track of where reviews are at, stuff like that, so that the managing editor's job doesn't get too overwhelming. The other thing we did sort of just before that process is we were looking at what we needed in terms of peer reviews. So it was always the case that there was a scientist and an education peer reviewer, but the earlier versions were very open-ended, and that sort of works really well when there's been a long culture of review, such as in astronomy research, where by the time you've been 10 years in the game of astronomy and you get given an article, you basically have a blank sheet of paper and you write a review and send it back because you've seen people's reviews of your work and you've done plenty of reviews before, and the editors let you know whether the review is acceptable or not. So there's this kind of unspoken culture that's developed over centuries of peer review in astronomy. But in astronomy education, there's not so much. In a sense, the science reviewers in AstroEDU obviously have more of a background with peer review, but education reviewers, as in straight up teachers, straight up educators, people who aren't researchers but who have expertise in education that we're looking for with AstroEDU, don't have a culture of peer review. And also some of the scientist reviews that we're getting back weren't really commenting on what we needed to know about the activities. So instead of handing the AstroEDU activity out and asking just for a review back on a blank sheet of paper, we thought about what questions we'd like to ask both the scientist and the education reviewer, and the question sets are different for each. So let's have a quick look at those. So here's the first half of the education questions. So the educator questions are more to do with how the students or the users are going to interact with the activity and whether it will work and what impact it might have. So obviously the first point of call is it original? But then we step through and look at, are there concrete statements for how students will demonstrate their learning? Are there evaluation methods and techniques that the teacher can use to understand student learning? Is there enough information for a teacher to actually pick it up and run with it in class? Kind of impacting the students' learning and their understanding of scientific practices. Does it increase their attitudes? Do they understand more about science? Does it develop their identity? These are all questions that are not something that a scientist necessarily has the expertise to answer. I mean, we can all have our opinion of whether an activity will do these things, but it's really the teachers who are in the classroom day in, day out, or in the planetarium or whatever education setting that they're in, that really has a kind of a good intuitive feel for how an activity might impact on students prior to actual classroom testing. And then there's some more, is it well written? Is it high quality with accurate content? And whether it's going to be useful or not. Is it appropriate for the age level? Is it going to be successful in the time suggested? And is it connected to a curriculum? To do something in the classroom, teachers need to connect it to a curriculum statement in their country. It's hard for someone to match their activity to the hundreds of thousands, well, hundreds to thousands of curricula around the world, but at least some attempt to put it into their local curriculum so that you know where it sits in high school, middle school, primary, undergraduate, planetarium, informal settings. So these next two are more about the scientist content, scientist review. So these are more about the science in the activity. So does the science content seem accurate? Is the content explained in depth? Is there going to be misconceptions created through the activity? Keeping in mind the actual age group of the students, is it appropriate and kind of authentic scientific approach, even though it may be a much more reduced or basic version of what an actual science would do in professional terms. Does the methodology and mathematics represent a scientific approach? Is it similar to authentic science? Does it help them understand scientific practices and identity? Does it provide enough background information? And then it's based back into, is the activity well written? Is it feasible? Is it too long or short, etc. There is also an open-ended section for both reviewers, but these are the kind of the questions that we're trying to pull out the exact kind of things that we are looking for. After this, there's an open-ended section that can be as long as the reviewer wants, and we'd expect reviews in that section because each activity will have aspects of it which won't be captured by these generic questions that we're asking. So the peer review process has these specific questions and then the open-ended opinion from the expert. So basically, the way to be an excellent reviewer is to sign up to be a reviewer. The three main things that we're looking for is, can you pick up the activity and run with it? The criteria is, can the activity run as is, as long as there's some reasonable amount of preparation. So just can't, obviously to do something new, you can't have zero preparation, but you also can't just rewrite the whole activity from scratch. Otherwise, there's no point providing that activity. And of course, is it educationally and scientifically sound? So those are the things to think about for being a peer reviewer. So looking forward from here, from where we are now with AstroEDU, is we're looking at what activities do we have. At the moment, they're kind of evenly spread through primary, middle, and secondary school. We have a much less focus on undergraduate and informal context, which is to be expected. We're currently working on an analysis where we're looking at what we have and then comparing it to what we need. But what activities do we need? What are the gaps we have? So we don't want thousands of activities necessarily, because otherwise we just go back to the old problem. We just become a big Google thing where you type something in and it's just overwhelming and you slowly walk backwards or spend too much time trying to look for what you want. What we want is well-tagged, high-quality activities that cover all of the aspects of the curriculum around the world, and then other high-quality activities that don't necessarily cover bits of the curriculum. So we're currently drawing to an end of analysing what we need, and hopefully by the end of the year it'll be set out in a paper. So there's the OECD Curriculum Review, which was led by Saeed Salampur, looking at about 50 different curricula. We picked the OECD and China and South Africa just because you have to limit it somehow. So that went through and had a look through what are the content areas, just like the basic Earth, Sun, Moon, seasons, what's out there in the curriculum, and in what countries and at what year levels. The other thing that we can draw from is the Big Ideas document. So we have, it's a big document about what's the big ideas in astronomy. Now, there's versions of this for other areas of science as well. Basically, it's trying to capture what the ideas are that an astronomy literate person would know. So perhaps, for argument's sake, it could be if you're an adult and you've learnt the simple to the complex ideas throughout your schooling, and to be considered literate in astronomy, what are those simple ideas? Well, not simple, but what are those fundamental ideas? And so the big ideas steps through a whole bunch of different domains. There's 11 of them. So they're broken up into 11 domains, and within each domain, there's about 10 or so specific content elements, and then you can jump in and go down a bit further, and there'll be a paragraph about each of those elements of that big idea. So just as an example of matching them up, I just pulled these out, so it's a little ugly, but pulled out a few of the curriculum statements about stars, and then you have big ideas. There's some of the ideas from the star section of big ideas, and then we have particular activities in astroEDU that address that. And so the process at the moment is marrying those three together. What do we have in astroEDU? What's in the curriculum worldwide? What's in the big ideas? And what do we need? And here's ones for cosmology. We have stuff about dark matter and the universe and how big it is, etc. And eventually what we're working on is getting this kind of summary table here, which will be fleshed out quite a lot of detail in the paper. You have a big idea column, so 1 to 11, and then there's some that aren't in the big ideas. Then the OECD categories, so what elements of the curricula, so we have history, optics, celestial motion, stars, etc. So they match up between the big idea and the OECD, and then these are color-coded by where they are in the OECD curriculum. So the OECD curriculum is highly dominated by celestial motion, mostly Earth, Sun, Moon, and seasons. But you find a variety of different topics at different year levels. So cosmology, there's a lot of it, but it's mostly in year 11 and 12. Space exploration and measurement are kind of evenly distributed. But you find most of the topics, other than celestial motion, up here in lower to middle to high school. And so what priority do you give different activities at different year levels? So celestial motion is very high priority for lower year levels, as is planetary science, which kind of comes in early when people look at the solar system. But gravitational waves isn't as important until you get up to the upper high school level, although I am sure someone would disagree with me on that. So it's up for debate. But basically, getting a kind of picture of OECD curriculum, big ideas, what we have in astroEDU, and what we can ask the community to try and submit activities to fill in the gaps. So if you do have an activity to fill in the gap and you'd like to submit it, how do you do it? Well, basically you go to the astroEDU site. Down the bottom, on the bottom left, there's a submit button, and it will send you to here. This is the front end of the Open Journal System site. I mean, most of the information is here. The main thing that drives it is the submission form, which is in MS Word or rich text format. And basically you get your activity and then you put it into the form that astroEDU has it. So it has different sections for each requested thing. There's a lot more than this. This is just an example. So this is on the left is some of the more technical stuff up the top, and then on the right, these sections are usually pages long. You know, the goals and the learning objective, background information, etc. But fill it out, and then you submit it to the OJS system. We'll check it over, and then if it's good, it will go out to review. So most of the activities in astroEDU are some type of inquiry learning, some type of hands-on experiment, but that's not the only activities that are useful in an education context, as teachers will have continually pointed out to me. Inquiry-based learning's all well and good, but sometimes you need something else. Sometimes you're doing a reading course, for instance. Or if you're teaching like 400 people in a lecture hall, there are particular ways you can do that, which are not just 60 minutes of you talking at them. How do you make spontaneous activity happen with 400 people? Some people are expert in that. That's not me, by the way. Some things you can do role-playing, drama, performance. So while most of the activities are probably going to fall under inquiry-based learning, discovery, science experiment, there's a whole lot of other different types of activity that you should consider submitting as well. And also to point out, we don't just take astronomy activities. We also take activities that are to the side of astronomy as well. So we have astronomy scientific categories, which we're all familiar with, but then also Earth science and space science, because a lot of the time there's an overlap between all three of these, and particularly in many curricula around the world, Earth and space science are connected together, and astronomy falls into Earth and space science. So they all kind of exist together in the primary, middle, and high school curriculum in a lot of places around the world. Last but not least, there will be soon a call for the chief editor of astroEDU. So it's about time for me to move on and to pass it on to someone else. So I highly encourage any of you who are interested in promoting astronomy education through high quality activities that are peer reviewed and provided for free to consider applying for the chief editor position of astroEDU. So thank you very much.